All right, fundamental theorem basic, example 2. All right, so the problem that you're given is something like this. So solve this thing. Okay, so remember, we'll think of dH dt as sine t. When this is the derivative, the change in h is this thing. So we're going to compute the change in h. Now we could do this with a graphical, so graphically, but the problem is that sine is not a straight line. The graph of sine is not a straight line. So it's hard to compute with a graphical argument. Here's one period of sine. Let's see. This would be 1 pi over 4, 2 pi over 4, 3 pi over 4. Okay, right, so what we want to compute is this little piece of area here. So what we're doing right now, what we are doing right now, is we're computing this area. Computing that area there. If this is the graph of dH dt, then this area is the change in h. Right, and that's what this thing stands for, is this area here. Okay? Now to do that, right, it's not going to be as easy as when we had straight lines, because with straight lines we have the areas of triangles. Or if it was a horizontal line, then we'd have area of a rectangle. But here we have this curvy piece on top, so it doesn't quite work. And just like those. So we'll have to use the second method, where we find h of t. All right, so right now we have h prime. We're going to find h, and then we'll evaluate the endpoints. Let's see. Okay, so now I check my work. Okay, now you might have noticed that this isn't entirely correct, right? So I never really remember if the antiderivative of sine is cosine or negative cosine. I just check my work. Okay, so I know it's either cosine or it's negative cosine. So I write down cosine, and I think to myself, what's the derivative of cosine? Cosine is negative sine. This is a positive sign. So I need to adjust by a negative. Now, h prime of t is negative. Derivative of cosine is negative sine. Negative sine is sine. So it checks out. All right, so I have h of t. H of 3 pi over 4 minus, so change in h. H of 3 pi over 4 minus h of pi over 2. Okay, this is negative cosine 4 minus, oh, I forgot my plus c minus cosine negative something there plus c, minus and minus make plus, so plus something there minus c. So you can see that the c's cancel out. Right, this is always the case. All right, so let's see, cosine pi over 2. Draw my circle here, my unit circle. Pi over 2 puts me there. Let's see. I go over 0 and up 1. Okay, cosine is the x. So the x at that point is 0. So a big 0 there. Okay, now cosine 3 pi over 4. All right, this is where you can use this idea. All students take calculus. So only sine is positive in the second quadrant. Let's see, this is, so 3 pi over 4 is puts us about there. Okay. So this is negative root 2 over 2. So we get root 2 over 2. Root 2 over 2 is positive, right? Root 2 over 2 is positive. And remember when we drew the graph that the piece of area that we were computing was above the t-axis? So this makes sense, right? That it's positive and we had an area that would be attached to positive with this thing. If we had gotten a negative, let's say that I forgot to put in that negative there, and I had a negative, you would know that something would be wrong, because thinking about what piece of area we were finding was above the t-axis, that the answer should be positive. So anyway. All right, that'll be good.